Let's use this as our first division problem. Now we have a two-digit number. I've used the zero number 90 because, again, this is a little easier if you're going to be starting with two-digit divisors. But we really do have to figure out where our first partial answer is going to go. So we're trying to find a number over here that's larger than the 90. 4 is not. 41, no. 411, yes, that will work. So the very first answer that I'm going to put up the partial quotient is going to be with this much of the number. Now to pick a number that would go into 411 more precisely, but this is still, we're still estimating and rounding and kind of guessing at it too, is we're just going to take the very first number and consider 9 goes into 4. No, that's too small. Into 41? Yes. What times 9 is close to 41 without going over it? And you would, from your multiplication tables, because you know those, you would say 4, because 4 times 9 is 36. So the 4 is going to go above the darkened number here, and we'll multiply back. 4 times 0 is 0. Do you notice I have it all in a nice straight line? And 4 times 9 is 36. This is where I can subtract. 1 take away 0 is 1. I'm going to have to borrow here. I'll borrow 100, and it comes over as 1 next into the tens column. So I'm taking that 100 and I'm giving it 10 tens. 11 take away 6 is 5. And 3 take away 3 is 0. 51 is smaller than the 90, so I can bring down my next number, 4. And the thinking process is so much easier if I just do the first number, 9, into 5 is too small, 51 is bigger, so I can use that. 5 times 9 is 45, so I can put it up here. 5 times 0 is 0. 5 times 9 is 45. Here I'm going to borrow 1. 11 take away 5 is 6. And 64 is smaller than 90, but there are no more numbers to bring down, so my remainder is 64. Let's do partial quotients this way this time. Let's find out where our very first number would go. 80 goes into 5, nope. 53, too small. 532, yes, it goes here. But to choose an actual partial quotient, I'm just going to look at the 8. 8 goes into 5. No. 8 goes into 53. Well, what times 8 is close to 53 without going over it? You might say 8 times 6. 8 times 6 is. So we're going to put a 6 here, and we have a 0 that needs to be considered because we have another place value after the 2. Let's get rid of our 2 zeros. Then 8 times 6 is 48. Let's do the subtraction. Here's a borrowing that we need to do. 13 take away 8 is 5. Again, 80 goes into 523. Woo, too hard to think about. But 8 goes into 5, no, 52. 8 times what is close to 52 without going over it? Well, a 6 again. But this time we were going into the whole entire number, so all we need is a 6. 6 times 0 is 0. 6 times 8 is 48. Subtract again. 3, we need to borrow here. 12 take away 8 is 4. 43 is definitely smaller than 80. We can add up our partial quotients. That's 66, remainder 43.